Okay, you say. Great. We can take the log base 10 on the calculator. It won't have escaped your notice that most bases are not 10. What if we want to take the log in any old base on the calculator? It depends, unfortunately, on which calculator you have. If you have the latest TI-84 Plus calculator, your math menu will look like my math menu. I go to the math menu and I scroll all the way down to the bottom and I see this log, then capital letters base. When I select it, it gives me a place to enter a base and a number. And then if I want to find, say, the log base 8 of 16, I would punch that in just the way it looks on my paper. And I can even convert that to a fraction, provided it's something nice. And I get that the log base 8 of 16 is exactly 4/3. Now, we didn't tell you explicitly that you had to have the very latest TI calculator for this class. So maybe you don't have it. If your calculator does not have a log base button, there is a formula whose derivation we're not going to talk about at all that says to take a log in any base, you can take the common log and divide it by the common log of the base. So if I want to take, again, I'm going to take log 8 of 16. That's going to be the common log of 16 divided by the common log of 8. Let's see what happens when I put that into the calculator. Notice I'm making sure I close the parentheses around the number I'm taking the log of. I get the same thing, and my calculator is even still smart enough to convert it to a fraction. Notice I don't want to take each of these logs separately, right? The common log of 16 is some horrible decimal. The common log of 8 is some horrible decimal. I don't want to copy out these two numbers and then divide them. I want to put the whole thing into my calculator at once. Now, depending on your calculator, it may not be smart enough to convert something like this to a fraction. Why? Because it's getting decimal approximations for both of these things, and it might not be able to tell that it's exactly 4/3. If you get a decimal that looks like it ought to be a nice fraction, you should try it and make sure that, of course, we can know that the log base 8 of 16 is 4/3 because 8 to the 4/3 power, that's the cube root of 8 to the 4th power, right? Which is 2 to the 4th power, which is in fact 16. So we know that this is exactly 4/3 because this actually works out. If you're using this method and you get something that looks like it ought to be a nice fraction, take a guess at the nice fraction and see if something like this works out. So let's just practice using whichever method you're using on your calculator. Compute each of these logs on your calculator. Pause the video and try this now. Okay, I'm going to put these in using both methods. To find the log base 2 of 128, if I have the log base function, I'll do log base 2 of 128, and I get 7. If I don't have that function, I'll do log of 128 over log of 2, and again I get 7. This is exactly 7. log base 5 of 72. If I have that log base function, I'll say log base 5 of 72, which looks like a dreadful decimal. Yeah, I don't think that that fraction is particularly useful. I'm going to do this decimal to 3 decimal places. If I don't have the log base 5 function, I'll just say log 72 divided by log 5. And notice I get the same decimal. To 3 decimal places, this is about 2.657. And finally, the log base 1/2 of 80. Oh, that's a negative number. I'm not real surprised by that, though. If I don't have the log base function, I'll say log 80 divided by log 1/2. Same decimal. To 3 decimal places, that's about negative 6.322. Just to make sure, this statement is the same as saying 2 to the 7th is 128. 5 to the 2.657 ought to be about 72. And 1/2 to the negative 6.322 ought to be about 80. So 2 to the 7th is exactly 128. 5 to the 2.657, yeah, that's pretty close to 72. And 1/2 to the negative 6.322, that's pretty close to 80. All 3 of those work out the way we hoped they would.